Hey guys, welcome to Mathletics. Today I'm going to talk about exact differential equations. So suppose you have an equation which can be written in the form m plus n dy over dx is equal to 0, where m and n are just two functions in x and y. Now, if the partial derivative of m with respect to y turns out to be equal to the partial derivative of n with respect to x, then we say that this equation here is exact. This check is what you will do to see if an equation is exact and then proceed from there. So once we know that the equation is exact, if we can find a function f where the partial derivative of f with respect to x is equal to m, and with respect to y is equal to n, if we can find such a function, then we can use it to get a solution to our exact equation. How? Let's see this through an example. Let's say we have 4x squared minus 1 plus 2y plus 8 dy over dx is equal to 0. Now this is in the form that we want, which is this. We have our m right here and our n right here. To perform our check, we say that the partial derivative of m with respect to y should be equal to the partial derivative of n with respect to x. So my here is 0. And nx is also 0. So they're the same, which means that this equation proves out to be exact. We said here that the partial derivative of f with respect to x is m. So let's write that down. So fx is equal to 4x squared minus 1, which is m, and fy is equal to 2y plus 8, which is n. Now, if you integrated this with respect to x, you can find f. And this turns out to be 4 over 3 x cubed minus x plus c. Now notice that since we integrated with respect to x, we can take this c as a function of y. Now we say this because suppose we had the function 4 over 3 x cubed minus x plus y, and we took its derivative with respect to x, we would get 4x squared minus 1. So the point is that this stuff vanishes when taking a derivative with respect to x. So if we integrate with respect to x, chances are there might have been something with respect to y. So all in all, we are going to regard c as some function of y. So f of x and y becomes 4 over 3 x cubed minus x plus s of y. Now if, just to make things clear, I will highlight this in green too, so you know where it came from. Now if I took the partial derivative of this f of x and y that we found with respect to y, I get just s prime of y. Now right here, we said that f of y, partial derivative of f with respect to y, is also equal to n, which is 2y plus 8. So we will equate these. So if I integrate s prime of y with respect to y, I get y squared plus 8y. So now I can substitute this here. So fx of y is equal to, f of x and y, sorry, is equal to 4 over 3 x cubed minus x plus y squared plus 8y. We're almost done. Now we cannot write our solution as a function f, because that is a function we use to find our solution. So we will just equate our implicit solution, which is this, and equate it to an arbitrary constant. So our final solution will look like this. Let's see one more example. Now suppose you had 2exy plus y squared plus 2xy plus 2e to the x plus 1 dy over dx is equal to 0. Now we need to recognize that this is m and this is n. So I check the partial derivative of m with respect to y is equal to 2ex plus 2y, and partial derivative of n with respect to x is 2y plus 2ex. They're the same, so this is exact. So as before, we say that a partial derivative of our function f with respect to x is equal to m, which is 2exy plus y squared, and fy is equal to n, which is 2xy plus 2ex plus 1. Now, integrating this with respect to x to find f, we have 2exy plus y squared dx, and this is equal to 2exy plus xy squared plus, we regarded this as s of y. Now, if I take the partial derivative of this with respect to y, this is 2ex plus 2xy plus s prime of y, which is equal to all of this. So 2xy plus 2ex plus 1, this gets cancelled from this gets cancelled from this. All we have left is s prime of y is equal to 1. Now if you take the integral of this with respect to y, you get y. Substituting s of y right here, we get 2e to the x y plus xy squared plus y. Now, as we've said before, this is just an implicit solution, and we are going to equate it to an arbitrary constant. So we have 2exy plus xy squared plus y is equal to c. And that is our final answer. I hope this video was helpful for you guys and you guys understood the concept and the equations and the solutions were all helpful. And if they were, share it with your friends and subscribe to my channel for more such videos. And I'll see you guys very soon.